Hi folks, this is the second video over factoring. And so we'll go through a few of the harder problems and also maybe some stuff that you haven't seen before and so forth. Okay, so I'm going to start, once I'm connected here, with a problem, a trinomial problem, which is similar to what you guys had on the last video if you watched that. And so let's factor 6z to the 4th minus 13z squared y minus 5y squared. Okay, so when you're first looking through this, the first thing you'd always do is look to see, can you take out a greatest common factor? In this case, you can't. There's nothing that divides into 6, 13, and 5. And then there's not a variable that all three terms have. So the z and y does not exist in all three terms, okay? So that's the first thing to note. So can't do greatest common factor, but there are three terms. So the only method we have to do is the trinomial method, okay? So the variables are certainly a little weird, but if you take a look at the coefficients, that's really what you need to look at to get started. So we'll start by taking 6 times -5, which is -30. And let's try to find two numbers that multiply to -30 and add together to give us -13, which is going to be -15 and a +2. Okay. So once you find these two numbers, those two numbers are what you're always using to replace the middle term with. And so we're going to do that likewise. The difference here is that when we replace it, we're going to put a z squared y on both the 15, the -15, and on the 2. So that'll look like 6z to the 4th minus 15z squared y plus 2z squared y minus 5y squared. Okay. Once you get to this point, then you just do grouping from here. Okay. So looking at those first two terms, the greatest common factor will be 3z squared. So we'll have 2z squared minus 5y in the parentheses. And then when you get to the second two terms, well, nothing divides into 2 and 5, but both terms have a y. So we can factor out a y, it'll be a positive y, which gives us 2z squared minus 5y. And so we have the same thing in both of those parentheses like we need. So our answer is going to be 2z squared minus 5y times 3z squared plus y. And that's our answer. Okay. All right. So let's take a look at some formulas, okay? So we have two formulas that we're going to go through, that I'm going to go through with you. One is called difference of cubes. And the other one is difference of squares. I'm sorry, that's not right. Sum of squares. Sum of cubes. I'll get it here eventually. All right. Okay, so let's talk about difference of cubes first. So this is where we have two terms and or a binomial, and both terms in the binomial are perfect cubes. And so to factor this, we'll use a formula. So let me write this out. Okay, so whenever you're factoring difference of cubes, your answer is going to be a binomial and a trinomial. Okay, and I'll kind of explain that formula a little bit more once we go through a problem. The sum of cubes formula is almost exactly the same. The difference is you're starting with a binomial where you're adding together two cubes. And the only difference is the signs. So a plus b, and then a squared minus ab plus b squared. Okay, so let's go through. We're on number 3, aren't we? All right, x cubed plus 27. Okay, so in this case, both of these two terms are perfect cubes. Cube root of x cubed is x, cube root of 27 is 3. Okay, so when we talk about a and b here, a and b are the cube roots of the two terms that we're starting with. Okay, so as we apply the formula, a is x and b is 3. Okay, so kind of you either need to make a mental note of that or at least write it down. All right, so when we factor this, then we're doing sum of cubes because it's addition. And so the first binomial is just a plus b, which in this case is x plus 3. And then the trinomial following it is that, well, the first term is a squared. Well, if a is x, then we're going to square that to get x squared. Then we have minus. Then we multiply a times b together. So x times 3 is 3x. And then the last term is b squared. So in this case, b was 3, so we square that to get 9. And that's it. That's our answer. Okay. So a couple things about this one. So there's really not a lot of work to be shown. In fact, it's just you're just writing out the answer from the formula. So you have to know the formula and understand it. Then it's just you writing out the answer. Okay. The signs, make sure you know the signs. So you're going to follow the signs from the formula. Anytime you're using a formula to do something, that kind of trumps if you have positive or negative numbers. So just follow the signs in the formula every single time. Okay. And there is a pattern when you look at these two, that really the first two signs are different when you're comparing difference of cubes and sum of cubes. The first two signs are different. The last term of that binomial is always positive. Okay. The other thing is whenever you're doing difference of cubes or sum of cubes, the trinomial can never be factored. So you don't have to worry about trying to factor that. Okay. In fact, there are no numbers that would multiply to 9 but add to -3. Okay, so in this case, both of those polynomials are prime, so it's completely factored. Okay. All right, so let's try another one. N cubed minus 8. Let's do another variable. Let's do n cubed. Okay, so again, both terms are perfect cubes. And so the cube root of m cubed is just 8. So cube root of m cubed is m. Okay, so a is m. And then the cube root of 8n cubed is 2n. So b is 2n. So m and 2n are what we're plugging in for a and b into the formula above. Okay. Okay. So in this case, it's difference because of subtraction. So we're going to use the top formula. So the first binomial is the m minus 2n. And then for the trinomial, for a squared, well, a is m, so m squared plus a times b, so that's going to be m times 2n, which is just 2mn. And then the last term is b squared. So if I square 2n, that gives us 4n squared. And so that's our answer. Okay. All right, last thing we're going to go through is what's called factoring by substitution. So let me write the problem out here, and then we'll go from there. Okay. So when you have a problem like factoring by substitution, so notice when you first look at this problem, looks kind of complicated, right? Okay, so that's kind of your first thing you want to recognize is that we have this binomial that's being repeated. It's squared in that first term and it's not squared in the second one. So that's kind of our clue that we want to use substitution. And so what we're going to do is the book always uses u whenever we do substitution. So we're going to say, let's let u equal 2a minus 1. Okay. So if that's the case, then I can rewrite that original problem to say 10u squared minus 19u minus 15. Well, this problem doesn't look too bad. Okay, it's like the trinomial problems that we did in the first lesson. So if we take a times c, 10 times negative 15 is negative 150. And then you have to figure out what two numbers multiply to negative 150 and add to negative 19, which are negative 25 and 6. Might take a little time to find that, but that's what they are. Okay. So we can rewrite that as 10u squared minus 25u plus 6u minus 19. Okay. Okay, so from the first two terms, we can take out a 5u, which gives us 2u minus 5. And from the second two terms, silly me, I wrote this down wrong right there. The original problem is right, but that should be a 15. So you guys probably noticed that. And we're probably yelling at your video that I was writing that down wrong, but I figured it out finally. Okay, so that should be minus 15. All right, so that works out a little bit better. So then I can take out a 3 here, which gives me 2u minus 5. Okay, so that's what we get when we factor that. Okay, now I'm not finished. So what we've done at this point is all we've done is we factored just this polynomial that we created right here. Don't do that. Okay, but we need to factor, we need to have something that really factors the original problem, which it was actually the variable was an a, not a u. Okay, so once we get to this step, then we have to resubstitute or unsubstitute, however you want to put it, this 2a minus 1 in for each u. Okay, so what that looks like is for this first factor, that's going to become 2 times, and instead of u, we're going to plug in the 2a minus 1 minus 5. Then I've got to work this out. So that's going to give me 4a minus 2 minus 5, which is 4a minus 7. Okay. Then we've got to do the same thing for the second factor. So the 5u plus 3 is going to become 5 times 2a minus 1 plus 3, which is 10a minus 5 plus 3, which is 10a minus 2. Okay. So at this point, I'm just kind of rewriting here so things are right next to each other. 4a minus 7 times 10a minus 2. Okay. Now, do you notice anything about one of those factors? It actually turns out that the second factor, we can factor out a greatest common factor of 2. Okay, so the first factor, 4a minus 7, that's fine the way it is. But we do need to take a 2 out of the second factor. So let me do that first. So I'm going to have 2, then it becomes 5a minus 1, and then 4a minus 7. And that's our answer. Okay. Now, if we multiply that back together, you're not going to get exactly what you started with, right? And that partly that's because for this particular problem, what you're starting with is not something that's completely multiplied together. So it does make it a little bit hard to check. Now, what you could do is you could go ahead and take that original problem and multiply everything together. So yeah, that means you need to FOIL the 2a minus 1 squared, distribute the 10, then distribute the negative 19 to the 2a minus 1, combine all your like terms, and then you could factor from there. So that's an alternative way to doing this problem. It's just multiplying it completely together and then factoring it, okay? But factoring by substitution offers an alternative way. I won't necessarily say it's a shortcut because it's not always shorter, but it just does offer another way to get to the problem or get to the answer, okay? All right, well, that's it for this video.